Okay. And hopefully it'll stop blinking because I just clicked that. Okay. Okay, so we're going to talk about parabolas today. So parabolas are these U-shaped graphs here. Also, they're the graphs of quadratics. It's what those are called there. So a parabola is the graph of a quadratic function such as y is equal to x squared. Geometrically, okay, so we're going to talk about the geometry behind this and why we're doing all of this algebra we're doing today in here. But geometrically, a parabola is the set of all points in a plane equidistant from a fixed point called the focus and a fixed line called the directrix. Now, there is a ton of information in that one little statement right there, and that is what you're going to have to know in order to do what we're doing. So what they're saying is that this line, if you remember with the circle, a circle is all the points that are the same distance from the center point. Okay, so we could talk about distance there. Here it's a little bit different. So this says that it's a parabola is a set of all points in a plane equidistant. So that means that there's an equal distance between from a fixed point called the focus and a fixed line called the directrix. So if I pick any point on the parabola, so I'm just picking a random point on the parabola, I'll call it point xy. Okay, so I pick a random point on the parabola. Any point, I can do it over here, I can do it down here, doesn't matter where. Okay, but that point, the distance from that point to the focus, the fixed point, the focus, so the distance from, so I'm going to say the distance from xy to the focus is equal to the distance from, so it's again, it says it's equidistant from a fixed point and a fixed line called the directrix. So the distance from xy to the directrix, which is this line here. Now you got to be really careful about this one. From a point to a line, you don't measure the distance at a diagonal. You measure it at a perpendicular. So you would measure straight this direction. And what we know is that those two segments are congruent to each other. Okay, that's the geometry behind this. Once you get that whole concept down and that idea, then it becomes algebra. Okay, but you have to understand that idea. So again, this definition right here has a ton of information in it. But what it says is that there's an equidistant, so that's where the equal sign came from, between the distance from any point, and I just picked xy here, any point on the parabola to the focus, and that distance is the same from that point to the directrix. And when you measure from a point, you're good, from a point to a line, then you have to measure it at a perpendicular distance to it. Okay, so that's the geometry behind this. The directrix is the exterior line perpendicular to the line containing the foci of the curve. Don't worry too much about that. You're going to be looking at directrix and focus as you go through this. Parabolas can be at a slant. I don't know how else to say that to you guys. They can also be directly to the left or to the right. They can be up, they can be down, whatever. We're going to mainly just deal with ones that are either up or down just because of the basicness of those. But you could take the algebra further and go into more if you wanted to. Okay, so that's what we are working with today. This is going to be the big concept of today. Okay, so what we're going to do is the first example. I'm going to recommend that you get a piece of paper out or enough space to actually write this instead of trying to do it in your book, but that is up to you. So if you want to take a moment right now and grab some scratch paper, probably about a half sheet of paper it would be good. Yeah. You can try, yeah, as long as you don't write huge, you'll be fine. But it's going to be a long equation, so it's up to you how you want to do it. So. Okay, so select the equation of the parabola, focus at this, and directrix at this. So there are lists of the equations of parabolas and stuff, and you can memorize those and whatever. But what you're going to have to do for me, because this is geometry, is show me how you get the equation of the parabola. And it's all going to come from exactly what I just wrote, this idea that the distance from some random point to the focus is equal to the distance from that random point to the directrix. Okay, so that's what we're going to do on this. So first thing I'm going to do is sketch this so you understand what it looks like. So if I sketch this, the focus is at 0, 1/2. So 0 left to right, 1/2 up. And I'm going to put that point here. So there's 0, 1/2. And then my directrix is at y equals -1/2. So y equals on the y-axis, go to -1/2. And the directrix, we usually draw in as a dotted line because it's not actually part of the graph. So we draw that in. And again, this is y equals -1/2. That's right there. So we have those two. Then the parabola, if we understand kind of how these parabolas work, they're always going to open up toward the focus. So this parabola is going to be halfway between those, which will be at 0, 0, which are the ones we're going to work with. Okay, and then it's going to kind of open up around this. If you remember from Donald Duck in Math Magic Land, they talked about, and I briefly mentioned that there's our parabola there when they were talking about a searchlight. Okay, the idea of a light or of a flashlight is if you look inside a flashlight, it has like a metal aluminum, I think it is, casing, and then the bulb is here. So this blue here would be that casing, and that purple right there would be where they put the light bulb, because then the light bulb shines off of all of that casing in a certain way, and that's how it works. Okay, so there's a little bit of real world to that, but that's where kind of parabolas come into play there. But that's how the parabola is going to look. Okay, so I've got a quick sketch of it. Then I'm just going to think about this point xy. And again, it does not matter where I put it. I could put it as high as I wanted to up here. I could put it wherever I wanted to here. But wherever I put this xy point, just so that I can see it, I have to remember that the distance from xy to that focus and the distance from xy to that directrix, which in this case is vertical, are equal to each other. So I did a pretty good job drawing this because those are pretty equal. Okay, but that gives you an idea if you've drawn your parabola correctly. So let's get into the algebra of this. Distance from that point to the focus. So I know that the distance from, and I called that point xy because I don't know that point, and whatever point you pick will be xy every time. Okay, so xy to the distance to the point 0, 1/2. And that distance is going to be equal to the distance from xy to, and now this is where I'm going to do my first little step here. There is a point right here, and we do know the coordinates of that point. One of the two coordinates is a variable. Does anybody think they know what it is? Yeah? No, so it's an ordered pair. So you're going to have like an x and a y. Yeah. So what's the ordered pair? Yeah. Put your two ideas together. It's x negative 1/2. Now here's why. How far over is this point? It's over as far as that one is, right? Because these are vertical from each other. So it's over x units. How far up or down is it? Well, it's down as far as this green line is, which is down negative 1/2. So we're going from xy to x comma negative 1/2. So if we put those two ideas together, that's where we get it. Okay. If it happens to be left or right, it might be like negative 1/2 comma y, but there's going to be a variable in there. So now I'm doing distance formula. I'm into algebra now, a little bit of geometry, but I'm into algebra now. So over here, distance formula with this, okay? And it is a square root of, because we're thinking, if you think a squared plus b squared equal to c squared, the distance is actually the c, so the distance is actually the square root of all of this stuff, okay? And remember, a is the run, b is the rise, or vice versa. So if I'm doing this, it's a square root of, okay? A squared, so the run squared, which is the difference between x and 0. So I'm going to do x minus 0 quantity squared. And we are going to be what's called deriving these. So you're going to be showing how do you get to it. So start with distance formula and get to it. So I'm showing you that run. Okay, there's my run squared. Plus, show me the rise. So the rise between these 2 points is the y and the 1/2. It is best, because you can actually make a choice of which one goes first. It's best to put your variable first. So I see y and 1/2. I'm going to do y minus 1/2 quantity squared. Some of you might be thinking, why is it minus? Well, this, remember right here, this a value is the run. So it's how far from one to the other. You don't add to get the distance between them, you subtract. Okay, so that's what I'm doing there. That's where that comes from. It is also just straight distance formula. So if you want to use that, you can. Do the same thing with the other one. So square root of, because it's a distance. But I'm doing it between these two. So on this one, the run is x minus x quantity squared. See that? There's both x's there. Yes, it's going to easily simplify in a second. Plus my rise, I need to see the rise, so I have a y and a negative 1/2. Y minus negative 1/2 can be written as y plus 1/2 quantity squared. Okay. So we have that. If you want to write minus and negative, it's totally fine. But that's what we have. Now we're going to simplify. Again, we're really into the algebra here. This is really no geometry at this point. Okay, we're going to simplify this to get to the equation. And if you look at it, look at those options that are up there. They're pretty simple. So this should simplify quite a bit. Okay, any ideas on what we can do? Algebra here. Think algebra, yeah.
Well, that's just x squared there because it's x minus 0.
Okay, I like it. So this right here is just simply x squared. X minus 0 is just x. The parentheses aren't needed at that point. It is x squared. I like it. What else can we do? Yeah.
And x minus x 0, so that's just...
Yeah, this can just go away, right? 0 plus anything is itself. So if you want to fill it in with a 0, you can, or you can just get rid of it at this point. So those can go away. Okay, notice that there is a square root on both sides, yeah? Okay, if we have a square root over the whole side, I can square that side. And if you square one side, you have to square the other. It gets rid of the square roots. So if I square both sides of this, and now I'm going to rewrite everything because we've done a lot of simplifying here, okay? The square root and the square go away. So over here, I have x squared plus the quantity of y minus 1/2 squared equal to, over here, I'm squaring and square rooting, those go away. This went away, so I have 0 plus, I don't need the 0, so I just have y plus 1/2 squared. Okay, I'm simplifying it quite a bit at this point. Next thing I need to do here is I need to actually multiply out my parentheses. Okay, so I have this parentheses here and this parentheses here. Don't distribute the square. If you write out, just like I talked about yesterday, if you write it out double, most of you will not do it wrong. So I'm going to write both of these out because both of these I need to multiply out here. Okay, so I'm going to multiply those out. Y times y is y squared. Y times negative 1/2 is negative 1/2 y. Negative 1/2 times y is negative 1/2 y. And negative 1/2 times negative 1/2 is, come on, 1/4, okay? Positive 1/4 there. Negative 1/2 times negative 1/2 there. Positive 1/4. If you want to use decimals, you can, just so you guys know, if you like those better. Okay, so right now I have, over on this side, x squared plus all of that equal to, do the same thing over here. And what you're going to notice when you do these, it's way parabolas work, is it's going to be a lot of the same stuff. So over here, y times y squared, y times 1/2 plus 1/2 y, 1/2 times y plus 1/2 y, and 1/2 times 1/2 is plus 1/4. Okay, so I have two sides of my equation right now. Again, first thing I did, simplified. It's the x minus 0, whatever, the variable minus 0, the variable minus itself, and the square roots are going to go away. The second thing I'm going to do is multiply out my parentheses, and this is going to be the same process each time. Okay, the third thing I'm going to do is cancel things out that are the same on each side, essentially subtracting them from both sides. So I can subtract y squared from both sides, and the y squareds go away because they're exactly the same. What else can I do? What else can go away? 1/4, right? I have a 1/4 here and a 1/4 here. Do not cross off the 1/2 y's. Those ones are negative, these ones are positive. They're not the same. But I am going to combine them. So over here I have x squared minus what?
Minus 1.
Yeah, it's just y. 1/2 and 1/2 makes 1. So minus 1y or minus y is equal to, over on this side I have y. So I have x squared minus y equal to y. Okay. I'm going to combine my y's by adding y to both sides. Be really careful. This is where a lot of people mess up. They cross off their y's. They don't cross off. They're not the same. So add y to both sides. You get x squared equal to 2y in this case. And either, so you have to kind of look at this point. If I look at these equations, sometimes, just so you guys know, sometimes parabolas can be written in this form. Sometimes you'll write them with just one variable squared by itself. Notice the difference between yesterday. Yesterday, circles had an x squared and a y squared. We only have an x squared. You could also, with a parabola, only have a y squared. So you're going to have one or the other, not both. So if I'm looking at this and I'm looking at my choices all have y by themselves. So that's what I'm going to do here. So if you're like, why is she doing what she's doing? It's because my choices all have y by themselves. To get y by itself, I divide by 2. And that's going to be, either I can write it as x squared over 2 is equal to y, or it can be 1/2 x squared equal to y. And you should be able to find your option then, which is letter D there. Okay, so I got y by itself in that place. So steps through this. Understand the concept of a parabola. That's really the big thing here. There's not really a formula with parabolas. There's a understand the concept. Its distance from a point on the parabola to the focus is equal to distance from a point on the parabola to the directrix, and you have to find that point on the directrix. Second thing is set up those distance formulas. Third thing is simplify. So easiest thing to simplify, whatever the variable is minus 0, whatever the variable is minus itself, and get rid of the square roots. That takes you to this step. Then multiply out your parentheses because stuff is going to simplify. It doesn't simplify within the parentheses, but once you multiply it out, it does. So multiply out your parentheses, cancel out like terms and combine like terms. Okay, so that's what we did to there. And then at this step, it does sometimes change. It just depends on what are the options. Which way do we want it? Do we want it y equals? Do we want it x equals? What do we want? And so what are you looking for from there? Okay, but otherwise you're essentially done. In this area right here, you could be done, or you could solve for y. So that's what you're doing with that. Again, there will be a video of that if you need to see it again, but that's the process. You're gonna have plenty of practice with it, just not quite yet. So the second piece to this is exactly what we did with circles. So we talked about writing equations with circles, and then we talked about solving a system with circles. Same thing here. We wrote an equation with a parabola, and now we're going to talk about solving a system with a parabola. So if I look at this, find the points of intersection, if any, between y equals negative 3x squared and y equals 6x. So here, I know that I have a parabola in that first one because there is only one x squared, or it could be y squared, just so we understand that. There's only one squared in there on the variable. And I have a line because it's y equals 6x. That's a linear equation. Okay, so I have a parabola and a line. When you have a parabola and a line, they can intersect twice like that. They can intersect once. They can essentially the line can be tangent to the parabola just like it can be to a circle. Okay, or it could intersect never. So you have those options again. You're not going to get it to intersect 3 times. Okay, so once, twice, or none. So those are your options here. You can see that. There's 2, there's 1, there's none as possibilities here. And we don't have to worry about like which one is it. We just solve to figure it out. So in this right here, if I look at my parabolas and the way parabolas are going to set up, you almost always can use substitution again. So I have y equals 6x. So 6x is by itself and can replace y. So I replace the 6x in place of the y over here. I'm going to put it in that little space. Okay, so 6x replaces a y, rewrite this first equation. So 6x is equal to negative 3x squared. And you have to solve. Now here's where we're going to have some people get stuck, but we have to know our solving. We have to know our algebra here. You need this equal to 0 in order to solve. You cannot divide by x. You lose answers when you do stuff like that. So you need this equal to 0. I like to keep my x squared term positive. So since it's negative, I'm going to add 3x squared to the other side. And I'm going to write this in standard form. So 3x squared plus 6x equal to 0. Anybody think they know what you do here to solve? There's a word. Yeah?
Greatest common factor.
Okay, so we're going to factor, and greatest common factor is the factoring we use here. Okay, sometimes it might be factoring a trinomial. There's all kinds of things, but you're factoring here, and you have to know you're factoring. Greatest common factor is exactly right. Technically, I could divide by 3, but I'm not going to do that right now. I'm going to look at this. The greatest common factor is 3x. So both of these terms divide by 3x, but the 3x doesn't disappear. The 3x is my greatest common factor. And then I always call it the leftovers, but the leftovers are in here. So 3x times what is 3x squared? It's x. Or if I divide that out, I get an x left over. Plus 6x divided by 3x leaves a 3 left over equal to 0. If you do greatest common factor, you should be able to remultiply and get the same thing you started with.
2 left over.
Thank you. See? I know how to do math. Oh, that's not even an eraser. Let's try that again. Okay, 2 left over. Thank you, guys. Okay, so we got that, right? So 3x times x is 3x squared. 3x times 2 is 6x. Okay, then you set them equal to 0 and solve. So you set 3x, one of your factors, this is a factor, equal to 0. You would divide by 3 and get x equal to 0. Now, if you have a GCF, most of the time when you get into GCFs here, you're going to have an x equals 0 as one of your answers. Okay, because that's just how those work out. And then I set my other factor, x plus 2 equal to 0, and I solve, subtract 2, I get x equal to negative 2. So I got 2 answers here, 0 and negative 2. Now some of you are going to go straight to B. There is still a chance that one of these doesn't work. When you plug it back in to figure out the y value, if the y value doesn't come out, then one of those doesn't work. So just be careful with that. You also then need to find your y values that go with each of these. So I have x equals 0 and x equals negative 2. So I'm going to plug in x equals 0 and solve. And it doesn't matter which one I do. But if I plug in 0 here, 6 times 0 is 0, so my y value is then equal to 0, which does tell me that I have an ordered pair of 0, 0 for an answer. Okay, and then I plug in my x value of, was it negative 2? Sorry, I forgot. Yep, negative 2. Plug in my x value of negative 2. 6 times negative 2 is negative 12, so I got a y value of negative 12. Again, these go together. They're an ordered pair. It's not like this negative 2 can go with that 0. So this is an ordered pair of negative 2, negative 12, and it is the double answer there. So it intersects in 2 places. Okay, so solving a system. Okay, so those are the 2 concepts of what you're doing. You're going to get your own practice out of it. You're gonna have questions. You're gonna ask about them. Let me stop this.